Okay, so today I'm going to be making a video with me actually in it, which is interesting because I hate doing videos with me in it. I don't do very good with them. But apparently my video tutorials are boring and you would rather see me in them. So enjoy, okay? Today we are going to be doing one on calculating wave speed. So this is what I have. This is the one I'll be working out, okay? So it says, and I'll put it a little closer. Oh, don't fall. It says, you have a wave speed of 27 meters per second and a wavelength of 3 meters. What is the frequency? Ooh, look at it. Read it. Pause it. Whatever. Okay, now I'm going to put it back. All right. So in order to work that out, let's just do a quick review, okay? Do you remember this buddy thing over here that I showed you guys? The little friend, the triangle, okay? Looks like that. All right. And then I also gave you guys a formula, which is this for calculating wave speed, or wave speed. So it's speed equals frequency times wavelength. Okay. There we go. So now frequency times wavelength, but now frequency is always in hertz. Remember, it's always in hertz, and the sign for it will be the F, right? And then speed will always be V, and the sign for it is meters per second. Ooh, I put these in the wrong parentheses. Sorry. There we go. Okay, and then wavelength is going to be this upside down Y looking thing known as lambda, and it will be in meters. Okay, so now I also showed you how do you make this go into your triangle. Anytime you have three variables, you can use a triangle. So how do you do that? Well, it looks like these two are multiplying each other. So these two are multiplying each other as well. Frequency times wavelength, frequency times wavelength. So I'm going to just do that. F goes here, lambda goes there, which means speed goes here. Okay, and here you go. I always like to write the units just so I remember them. Okay, you know me, I'm a huge stickler. Oops, Miss Duncan, what in the world are you doing? Sorry, hertz. Okay, meters per second goes there. Loud bell. All right, so that now our triangle is filled. And now, looking at this, you can actually use this triangle. So it says you have a wave speed of 27 meters per second and a wavelength of 3 meters. What is the frequency? So I can use my triangle. Here we go. So let's plug in numbers. 27 meters per second. What units do you recognize? Here, speed, right? So that would be going up there, 27 meters per second. A wavelength of 3 meters. What is the frequency? So now we already know it says wavelength and it also shows in meters. So we know that the 3 would go here, okay? And then we're trying to, what is the frequency? That's what we're trying to figure out. So frequency equals something. All right, so now in your calculator or in your head, you should be able to take 27 divided by 3. So the one you enter in first is the one that's on the top. So if I was to punch this in my calculator, I would punch in the 27 first, divided by the 3, and I get 9. So my answer is 9, but it's not done because I got to have my units. Hertz. There you go. All right. So now I'm going to erase that, and I'm going to go on to the next one after I spend my time looking for the eraser. Oh. Okay, so now the next one that I have is this one. It says a wavelength of 38 meters travels with a frequency of 8.33 hertz. What is the speed it travels? So look, there you go. If you need to see it up close, go ahead and pause it now to write it down or use your good eyes and look at it from afar. Either one. Okay, so again, popping out that little triangle. Bam, bam. All right. So it says a wavelength of 38 meters. So where does the wavelength go? Bottom right, right? Because it says it right here. And then a frequency of 0.833 hertz. Where does that go? Bottom left. 0.833 hertz. What is the speed? So V equals something. All right. So now, in this, you're going to just calculate. You're going to multiply. So, let's do it. 0.833 times 38 equals, and you should do this yourself. Pause it or something. Get the answer before I say it. The answer is this. Okay, 31.65. Yeah. And we're done. Okay, pause it. Do something. I don't know. High five yourself. Yeah. All right, so then the next one, or shall I say the last one I'm going to work out? This one's got a little more meat on its bones. It says you have a period of 0.56 seconds and a wave speed of 37 meters per second. What is the wavelength? So this is going to cause you to have to review CHM, which is calculating harmonic motion. All right? Because remember, with CHM, we had these two formulas. F equals 1 over T, or T equals 1 over F. Remember, T meaning period, and F is the frequency. Okay, so in this situation, it actually says you have a period of 0.56 seconds. So let's first of all try to fill in our triangle with what we got. Okay, so is there a place for period in here? No, but there is a place for wave speed. So that would be what, 37 meters per second. So what is the wavelength? So we're trying to figure out what lambda equals, but we got to figure out what frequency equals. But it gives us what the period is. You understand? So period, in order to figure out what frequency is, we're going to use this one. My bad. Wait, F equals T equals, let me just look at this real quick. So I got, oh, duh. This is how you find out what the frequency is. So I'm going to take this 0.56, I'm going to use a different color. To find frequency, I'm going to do 1 over 0.56, because this is my period, all right, seconds. And so 1 divided by, you actually have to calculate this, is going to give you this answer, 1.78. So those are my hertz. Now I can take those and stick them over here. So 1.78 hertz is my frequency. What is the wavelength? 37 divided by 1.78. Let's do it. 37 divided by 1.78 equals, there you go, 0.78. There you go. And that would be meters. So that is the wavelength. Hopefully that makes sense to you. Yay! Okay, I'm leaving now. Bye-bye.